Hello. In this session, I'm gonna talk about algebraic functions. There are a variety of algebraic functions, but my focus is mostly on polynomials and rational functions. First, let's talk about polynomials. A polynomial is defined as fx is equal to an xn plus an minus 1 xn minus 1 plus blah 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 till a0, which a0 till a1 they are real numbers and constant. They are called coefficient, and n is an integer, is a non-negative integer, is called degree. Let's take a look at one example. Example number 1 is called quadratic polynomials, which meaning polynomials of degree 2. It can be a2 x2 plus a1 x plus a0, or we can say ax2 plus bx plus c, and all of them a, b, and c, clearly they are all non-zero, so we don't want to kill any of these degrees. So if we take a look at the graph of this function, later we'll discuss how to graph these kind of functions, but just for the sake of the behavior of this function on xy plane, it can be it can have maybe two roots, meaning 2 points that hit the x-axis, x1 x2, or it can be something like this, meaning hitting the x-axis only once, or it doesn't hit the x-axis. We can later see that it all depends on term b2 minus 4ac. If this term is positive, we have two roots, x1 and x2. If this is equal to 0, it has only one root, and if this term is negative, we don't have any intersection of this graph and the x-axis. Now let's take a look at the rational function. A rational function is a function that can be defined by a rational fraction. Basically, a rational fraction is a function in which both denominator and numerator are polynomials. So if gx is a rational function, it has a top and bottom, both are polynomials. Now let's take a look at one example. A very simple rational function is ax plus b over cx plus d, and we can assume all a, b, c, d's are positive, and we can see both top and bottom they are polynomials of degree 1. So if we want to see the graphs, it's going to be something like this. We can discuss it later, but it's going to be something like this. Basically, these two lines are horizontal and vertical asymptote. This line, x is minus d over c. Why? Because we know that for x is equal to minus d over c, this function gx cannot be defined because the denominator is 0. So this function, if x is more than minus d over c, the function is going to be minus infinity. If this is less than this value, is going to be basically on the positive side, infinity. And this is going to be the root of this function. We can clearly see the root is going to be x minus b over a, because in x minus b over a, ax plus b is going to be 0, and this intersection with y-axis, basically x is 0. So when f x is 0, g0 is going to be b over d. So this point is b over d, and this is going to be when x goes to infinity. We can later see that the value of this function is going to be a over c is equal to y. Have a good day. Thank you.